This lab focused on observing and modeling motion in the same direction at the same speed. I was interested in understanding constant velocity of a system through the use of a fundamental principle of physics. Newton's second law states that the total interactions acting on a system from the system's surroundings will determine how it moves over a period of time. For this reason, Newton's second law of motion is a good fundamental principle to use to begin to study the motion or velocity of an object. It's important to understand some basics about this particular lab. I use SI units to measure quantities such as vectors. Units such as the Newton or kilograms times meters per second square is used to measure vector quantities for properties such as the total force acting on an object. All vectors have magnitude and direction, so the position vector r is made of components with magnitudes rx, ry, rz, in the I hat, j hat, k hat direction. If velocity is changing, we know some force is causing a change in the vector's direction, magnitude, or both. If velocity is constant, the total forces on the system have either canceled or there are none. Therefore, our starting velocity should be the same as our ending velocity. I videotaped the cylinder can, which is the system I chose, moving in the negative x direction based on the coordinate axis I also chose. The program tracker quantified my motion. I used the second and third position and time coordinates to set an initial velocity. I chose not to use the first position to avoid obtaining a higher velocity due to force applied to the can to launch the motion. I also chose adjacent points to analyze what happens over a small period of time. I used the starter code in VIDLE to obtain a model of my prediction. First, I initiated and set my properties with data I calculated from my observation. Next, I had to update my model. I set the duration of my loop to equal the time I observed in my video. I set fnet to equal the zero vector. I inserted Newton's second law to update my velocity. I further rearranged Newton's second law to update the position. And then I advanced the time. Though my predicted model seemed as though it matched my observation graphically, I used VIDLE to export a CSV file to quantify the data. Then I used Excel to plot a position versus time graph of both my observation and model. I calculated the slopes of each line to get my velocities and saw the first point of difference was at the thousandths place. My velocities matched pretty good. So to answer a couple of questions that I was presented in lab, I chose my axes to display motion to the left, but had I chose a different parameter, I would have seen that there was same velocity in the sense that it is uniform over the entire length of time in the same zero vector for net force. Is it possible to know what caused the zero net force in my observation? We may be able to determine contributing forces. However, we do not know why they have canceled. Thank you for watching.